In college algebra, we finished up combinations of functions. We looked at the composite or composition of functions. So the rule is right here. It looks a little confusing though. So the idea is put function g, like substitute, everywhere you see an x in function f. So for number 6a, this reads as f composite g, or in other words, f of g of x. So I'm going to put x squared plus 6, that's g right here, in place of the x in f. So I'll start writing, let's write this first actually. I'll start writing function f, and then right away I see an x, so I'm going to put x squared plus 6 in its place, and then write the rest of f. Then simplify, add like terms, and you're done. So our final answer on part A is 3x squared plus 14. And that's it. It gets a little more complicated on number 7, but let's do these first. So g composite f is g of f of x. I'm going to put 3x minus 4 in place of the x in g. So I start writing g, and right away I see an x. So let's write 3x minus 4 in place of that x. Then write the rest of function g. This one's a touch more work. You might write this twice so that you don't forget anything. Distribute, FOIL, and you get 9x squared minus 12x minus 12x plus 16 plus 6. Combine like terms, and you got it. For the last one, it's a touch more complicated because f has 2 x's. I have to take this and plug it right there and right there. And it asks one additional question, the domain. So make sure you're careful with your space. You'll run out of room quick. I'm sorry for the lack of space. But I'm going to cheat and write in the margin over here. F composite G is 6 over x over 6 over x plus 5. Those two fractions right here and right here are what I plugged in. I plugged those in place of the x's in function f. Then I need a common denominator in the denominator of the denominator. Need common denominator. So I can combine 5 and 6 over x. By the way, you're not allowed to just cross these out because there's a plus sign there. You can't do that. So you need to combine the two terms, and then we're going to flip it out and multiply. So we end up with 6 over x over 6x plus 5 over 1 times x, because x can be the common denominator. So naturally we have this. Now we can flip out that denominator and multiply two fractions, and conveniently something cancels. Now I can cancel. Those cross out. And we end up with 6 over 6 plus 5x. Now for this next part, we need to find the domain. Earlier in the handout, we were worried about square rooting a negative. We also need to worry about 0 in the denominator. So we need to exclude values that make the denominator 0. Whoops. So you set the denominator equal to 0 and you solve. So I'm looking right here and I set that denominator equal to 0, solve it, subtract 6, divide by 5, and that is the number right there that would make the denominator 0. So our domain is x cannot equal that value, but there's one more. What about, let me change colors. What about this x, this denominator? I know we crossed those out, but you have to acknowledge the very beginning, because what if we plug in values at the beginning? X cannot be 0, or you get undefined. So to finish it out, also 0. Oh, I wrote it on the wrong spot. There we go. Sorry. All right, that's the end. Have a great day. Bye.